Okay, so let's tackle question 3, part A, part 2. In this question, we are given that sine of A is equal to 3/5, where angle A is acute, and cos of B is equal to -1/2, where angle B is obtuse. And we need to express tan of A plus B in the form A plus B root 3, where A and B are real numbers. So what's the plan of attack? Well, from question 3, part A, part 1, we know that tan of A plus B is equal to tan of A plus tan of B over 1 minus tan A tan B. So by finding the values of tan A and tan B, we will be able to calculate the value of tan of A plus B. Let's find the value of tan of A. Given that sine A is equal to 3/5, where angle A is acute, it follows that angle A lies in the first quadrant. The right-angled triangle containing angle A would have the following sides. The side opposite angle A has length 3 and the hypotenuse has length 5. We would need to find the length of the side adjacent to angle A. Using Pythagoras' theorem, we find that the length of the adjacent side is equal to 4. Since tan A is equal to the length of the opposite side over the length of the adjacent side, it follows that tan A is equal to 3/4. Let's find the value of tan B now. Given that cos B is equal to -1/2 and angle B is obtuse, it follows that angle B lies in the second quadrant. The right angle triangle formed in the second quadrant would contain angle 180 minus B. Cos B is equal to negative cos 180 minus B because cosine is negative in the second quadrant. Hence it follows that cos 180 minus B is equal to 1/2. But cos 180 minus B is also equal to the length of the adjacent side over the length of the hypotenuse. So the adjacent side has length 1 and the hypotenuse has length 2. By Pythagoras' theorem, we find that the opposite side has length root 3. We are now in a position to calculate tan B. Tan B is equal to negative tan 180 minus B, since tan is negative in the second quadrant. However, tan 180 minus B is equal to the length of the opposite side over the length of the adjacent side, which is equal to root 3 on 1. So therefore, tan B is equal to negative root 3 on 1, which is the same as negative root 3. Okay, great. So we now have values for tan A and tan B. Substituting those values into the result we had for tan A plus B, which was tan A minus tan B over 1 minus tan A tan B, we get 3/4 minus root 3 over 1 minus 3/4 times negative root 3. Simplifying, we eventually get 3 minus 4 root 3 over 4 plus 3 root 3. There's an irrational number in the denominator, so we'd like to get rid of it. We do that by rationalizing the denominator, that is turning the denominator into a rational number. Notice if we multiply 4 plus 3 root 3 times 4 minus 3 root 3, we would get an irrational number. So we strategically multiply the entire fraction by 1, where we put 1 equal to 4 minus 3 root 3 over 4 minus 3 root 3. Doing the multiplication, expanding everything and simplifying, we would eventually get negative 48 on 11, which is our A, plus 25 over 11, which is our B, times the root of 3. This is the form we wanted the result in, so this completes the question. Hey guys, Dwayne here. If you're a Caribbean student struggling with Cape Pure Maths and you need extra help, then go to this link to join my free study group. Also, don't forget to subscribe to this channel and click the notification icon to get notified when I upload new videos. Thanks for watching and see you next time.